All right, in this next part of our series on introductory programming with C, we are going to look at what a struct is. So by the end of this video, you should be able to use structs to create more complex composite types in C. All right, so let's talk about how we have been able to group related pieces of data in some of the other programming languages that we've been using. So one type of data structure that we've seen is an array. And an array can be really useful, or depending on the language, you might have also used lists, right? This is a similar type of data structure. But there is one constraint that we have with arrays that sometimes gets in the way. So we can put lots of different pieces of related data into an array, but all of those pieces of data must be of the same type. There can be no mixing of types in arrays. So sometimes this isn't a problem, but if we want to represent something more complex, like let's say a person that has a string name and an integer age and a decimal, like a double weight, something like that, an array isn't going to work out for us very well. Luckily, we've worked with a lot of languages that support object-oriented programming, right? So we have the ability to create objects, and when we define objects, we can define different attributes that might be different types. So if we were trying to, let's say, represent this person object in something like JavaScript, we could write a person class and define some attributes like name, age, birthday, weight, all those things, right? And the types can be different and it's okay. So objects take care of some of the cases that arrays might not take care of, but they don't exist in the C programming language. Very sad. How do we get around this problem? How do we represent these more complex ideas that need multiple types for us to really accurately describe and model them? So how do we solve this problem? What is it that we use? In C, we use something called a struct, which is short for structure. So let's take a look at what that looks like. So here we have a sample struct that is used to model a pet, all right? How do we know that it's modeling a pet? Well, we've included something called the structure tag. This is an optional component in your structs. So for example, if you're creating a struct that you're just using one time, maybe you don't include the tag because you're not going to refer to it later on in your code. But I think including the tag makes it a little more readable. We immediately know what this structure is modeling. And if we want to create multiple pets, we can do so pretty easily. So tag is one component here. We also have the option, as we define our struct, we can create a few instances of that struct at the same time. Again, this is an optional component. You don't have to include this. You could create instances later on. And then obviously the other big component here in our definition of a struct is the keyword struct. And so in this example, we've defined three different components of our struct. We have a name, we have a breed, we have an integer, or we have an age. We see that we're mixing different types here. That's totally okay. If you wanted to add more attributes to this struct, you'd be able to do so, okay? But here's a short, sweet example of what a struct looks like in C. So let's talk about, okay, how do we actually use things like so in that last example, the name, the breed, the age, how do we use these different member variables of our struct, okay? And we're going to use something that you've probably seen in other languages that you've worked with. We're going to use dot notation, right? So let's say, for example, I define this struct that represents a pet, and then down here in yellow, you've seen that I've created an instance of this pet. Now you'll probably notice something that's a little bit different than what you're used to when you've created objects in the past. So not only did we have to include the keyword struct, we also had to include the tag, right? The the structure tag pet. So there's two keywords that we needed here to define, okay, what is this pet variable, right? To get around this, because that's kind of annoying if I want to create lots and lots of pets to have to type out two keywords every time. Wouldn't it be nice if we only had to type out one keyword? Well, there's a way to do that, okay? So if we include, so as we're defining our struct, if we include the typedef keyword, that allows us later on in other parts of the program to just refer to that struct by its optional tag. So then if I want to go create lots and lots of pets later on, all I have to do is use pet with a capital P to define the type, and then I can name that pet whatever I want. So typedef keyword is something that comes in handy, all right? So let's go ahead. So we have a pet right now. Pets have a name, a breed, and an age. We haven't assigned any values to those. So let's go ahead and modify some of these different struct members. So dot notation, we have the name of the pet we're trying to modify, which in this case it was just pet, okay? And I'm doing some things, I'm assigning some strings to the name, some strings to the breed, and then going ahead and assigning an integer value to the age using the appropriate C methods or assignment operations. If maybe later on I wanted to go in and then access those values, maybe to print them out, maybe to change them, whatever it is I wanted to do, I could, using that same dot notation, access those. So here I'm just printing out the two different string members using printf, and then same thing, we could print out the integer age value as well. So pet.age gets me the age, pet.breed gets me the breed, pet.name gets me the name. Pretty straightforward stuff. So to kind of recap, what can we use structs for? We know we can use them to model more complex things that we can't maybe represent with a string or an integer, or we have a mix of types. So we can't put all of this into an array. We can define structs and then create different functions that return those structs. That can be helpful. So they are an acceptable return type for different functions you write. We can pass structs as arguments to different functions as well. And we can essentially use them to create our own custom data types in C to handle different situations. So to sum everything up, unfortunately, very sadly, the C programming language doesn't support objects in the way that you might be used to languages like JavaScript or Python supporting objects. However, we can achieve some of the same functionality by using structs to model pieces of data that are more complex. They're composite pieces of data. They have multiple parts to them, right? Multiple attributes, multiple things that are associated with them. So keep that in mind as you are writing programs with these more complex elements that you need to model.